What's up, everybody? Welcome back. My name is Octavian. Today, I'm talking about what is chemistry and what you can do with a chemistry or biochemistry degree. So, before we go on, please like, comment, subscribe, hit the notification bell if you like the content. There's gonna be more coming soon. I'm just putting everything out. So, yeah, make sure to comment so I know how to improve. Yeah, so let's get right into it. So, what is chemistry? Um, the easiest way to put it is it's the study of matter. That's the easiest way to put it. And it encompasses various substances that have uh, matter and how they interact, combine, and change with one another. Um, so yeah, and there's so many different facets of chemistry because there's different aspects that you can focus on as far as just looking at chemistry. Um, yeah, so types of chemistry, right? Those are the different facets. First, you got organic chemistry. Second, you got inorganic chemistry. Third, analytical chemistry. A lot of people don't know about that one. Fourth, physical chemistry. And fifth, biochemistry. Now, we're going to start off with organic. This is probably the most common that people understand when they think of chemistry, just because of uh, what it is. So we get into organic chemistry. So organic chemistry is the study of carbon-containing compounds and their physical and chemical properties, composition, reactions, and structure. So you can get a degree in chemistry, and then focus, if you choose to go to graduate school, in organic chemistry. Or I know in some international countries, you can get a degree in organic chemistry, and there may be some universities in the USA that also allow you to get an organic chemistry degree. Now, with a organic chemistry degree, or organic chemistry focus, uh, you can you can work with plastics, rubbers, soaps, fragrances, pharmaceuticals, fuel, and like so many other uh, types of molecules. Because organic chemistry is just that broad. If without organic chemistry, we wouldn't be able to do so much in society. Um, so yeah, like fragrances like perfumes and cologne, rubbers with like tires, plastics. Plastics is huge in the world, and trying to decrease the amount of non-reusable plastic is a big thing. The organic chemists and like environmental chemists focus on as well, so you can be a part of that with your degree. Also, um, the organic chemists, they typically can become teachers, chemical engineers, uh, researchers, pharmacologists, and material scientists. Material scientists is relating to like the plastics and the rubber, like actual materials. In case that wasn't clear. So, following organic chemistry, we have inorganic chemistry. And with this picture, it's kind of understandable what inorganic chemistry is. So, inorganic chemistry is the study of everything that is not carbon based and does not have carbon based compounds. Um, it has a focus on metals and organometallic compounds. So, it discusses like in the picture that was shown, like the transition metals like iron, gold, silver. All of those are like um, all of those are included in organic chemistry, as well as compounds that um, are on the staircase border, the metalloids. That also is a part of inorganic chemistry as well, like germanium or things of that nature. Again, inorganic chemists tend to work on environmental sciences. They work with semiconductors. They do a lot of research, and then they work in geosciences. So a lot like just working with the environment and the planet. A lot of inorganic chemists uh, do work with energy and like getting semiconductors for like batteries um, that people have in like their phones and stuff like that. Inorganic chemistry is huge in like that environment. So if electrochemistry is something interesting or um, this if it's of interest to you, then this could be the route that you could go on. Next, we have analytical chemistry. So analytical chemistry is a study of chemical measurements and obtaining the information about compositions and nature of matter. So again, the focus is mainly on matter. But yeah, analytical chemistry is basically a lot of measurements. I took this class um, last semester in the fall, and it was heavily intensive on understanding how to get very accurate measurements and also being precise. And there's a difference between precision and accuracy. Um, but yeah, it was heavily focused on that. And like it was intensive on using like pipettes and Erlenmeyer flask and using burettes, focusing on dispensing. We did titrations. Later on in the semester, we end up using more expensive instrumentation like ATR, FTIR, XRF, XRD. Um, we did some chromatography, things of that nature. So analytical chemists tend to be material scientists, chemical engineers, researchers, forensics analysts, or doctors. They with the precision and accuracy that analytical chemists have to uh, abide by, and like what the premise of their method of like chemistry is. They tend to be in things that are very detail oriented and they have to be very exact in how they operate with certain chemicals. Um, so yeah, like a typical question that analytical chemist has or answers is something like how much carbon dioxide is in a 1 liter Sprite bottle. So it's like they'll determine like to maybe the nanoscale of like the amount of the moles of carbon dioxide in a sealed 1 liter Sprite bottle. So next up is physical chemistry. If you can see this right here, this is a Hamiltonian equation, something that physical chemists love. It's like quantum stuff. I just learned about this past semester. Very interesting concepts. So, what is physical chemistry? So, physical chemistry is a study of matter on the atomic and molecular level and applies physics concepts to understand uh, chemical structures. So, um, they take like regular species and look at it in a particle by particle basis or atom by atom basis, and or they can look at things like a singular molecule and focus on that, and look at a whole bunch of different physics concepts like the thermodynamics of it and the energy that that can be measured. They can be looking at the structure of a chemical, or and like the composition of certain materials at a very small level, to like probably like they can go all the way down to angstroms, which is 10 to the minus 10th meters. So tiny things. So physical chemists, they tend to be researchers, nuclear chemists. They can be a part of nanochemistry. They can do computational chemistry as well as astrochemistry. So it's they are the mix between like someone that loves physics and they love chemistry because they work in both facets. So they hit both bars in that sense, which is pretty interesting, and they can do some very interesting things with that with those characteristics. So now you got biochemistry, got DNA in the background. Biochemistry is like a branch off chemistry that is a lot of people. Actually, I can't even say that. I don't even know if people know about biochemistry like that. Like I coming into college, I didn't know there was anything called biochemistry. So it was something that was new to me when I found out about it. So what is biochemistry? So biochemistry is a study of matter in relation to living organisms. And with this, it studies the biological processes on the molecular and atomic level. So, yeah, all living organisms and their biological processes are kind of like they all are encompassed by biochemistry. So, biochemists tend to be involved in medicine, whether it be veterinary medicine, sports medicine, or just regular health professionals like doctors and nurses. Those are typically biochemist professions. Pharmaceuticals, which relate to all those species, just like for drugs to take for them. And pharmaceuticals also, if you see the crossover, organic chemistry as well, that's a common crossover. And then you also have food and drug sciences, because we consume those as humans. So biochemists have to make sure they're safe and they don't have any adverse effects on humans, along with animals and like their food and drugs that they may be induced with. And then you also have environmental protection, which is simply just like protecting the environment and the living organisms in the environment. So yeah, those are all the types of chemistry. So yeah, thank y'all for watching. Please like, comment, and subscribe as the video says. Hit the notification bell to get notifications whenever I upload. Yeah, I can make more chemistry videos where they can discuss the specifics of each field of chemistry, and we can go into the nitty gritty about the chemistry. Like the physical chemistry, we can talk about thermodynamics and quantum mechanics. Organic, we can go into like different organic molecules and structures, and we can go into esters and ethers and aldehydes and ketones. We can talk about that. Biochemistry, biochemistry and organic chemistry, to be fair, I have not taken yet. So the information I can provide on those is probably not the best. I think that that you are better with other resources for that. But yeah, physical chemistry is good. Organic chemistry, good. Analytical chemistry, good. If you have general chemistry questions as well, that is also something that I'm very willing to help with. I've also taken biology and physics, so I understand, like I guess like the entry level concepts of those, and they cross over with chemistry as well. So those things I am also able to help with. So yeah, again, thank you all for watching. I'll catch y'all. See you on the next video.